So what exactly is a cell in a cellular system? So basically the cellular systems, for the sake of more capacity and for the sake of mobility, they are divided into smaller coverage units. Those are called cells. Well, while that's a basic concept, what exactly is a cell? Well, the answer is a bit more difficult than it could seem at first. And in the next slides, we're going to explain that because there is unfortunately some confusion even in specialists. But in essence, also because you have more and more greater flexibility in terms of deployment, in terms of what a 5G system is, how you make a 5G signal be, how you deploy that, it's actually more and more difficult to identify and sell. And the next slides then will show actually how to overcome this confusion and understand quite exactly what a cell is. So first of all, a cell is always associated with a certain coverage area. So basically you are dividing your geographical area in smaller units of coverage, and those are called cells. So in the classical view, actually a coverage area of a site was a cell, and most textbooks you're gonna find some diagrams like this where you have hexagonal cells, and that's basically because it's easy to plot. It's also easy to make mathematical calculations on top of it. But in reality, the actual coverage of a cell may look much more something like this, which is completely regular, and you would need actually to use cell planning tools to actually come up with the coverage of each cell and even make drive tests to really verify that in practice. So what was a cell classically? So like if you see older textbooks, all of them will talk about a cell as the coverage area of a site. So basically when the cellular concept was introduced, instead of having a large coverage area with a single tower, then you have smaller towers, and each tower has a certain coverage area, which was the cell. And the confusion starts already like when we started working with sectorization. So like sectorization is very important for having more capacity and for reusing certain cell tower to have multiple cells on it. But in there was confusion. So like what nomenclature would go with? So like would you call then one cell with three sectors, or you would say that now that you have sectorization, have then a site with three cells? And basically some people adopted one nomenclature, some people adopted the other, and still to these days there are confusion on these concepts. So given these two different views, that you could think of a cell as the coverage area of a site, or that could think that a cell is actually a particular sector, we could have two views of the same network. You can see on the left side and on the right side the cell towers are located exactly in the same positions. But in the left side we think of larger cells, which are the coverage of a site, and the cell towers are located in the center of the larger coverage areas. Whereas on the right side, we have the cell tower located in the corner of three sectors. And basically those two views are equivalent. And also on the left side, we could think of the sectors. So it's just what unit of coverage we are actually naming as a cell. And both these views have been used in the literature, for example, to give reference scenarios, to make mathematical calculations, or to define simulation scenarios. But in one side, you would say this is a 7-cell scenario. On the right side, you would say it's a 21-cell scenario. But in both cases, you would just basically say you have 21 sectors. So it's much more precise to talk about the sectors, and there is no ambiguity in that. So there are also further concepts that make every time more difficult to understand how cells work. And basically we have not only three sectors, we can have, for example, in locations where you need more capacity to have 6 sectors. And you also have cloud or centralized run architecture where a single equipment would actually control multiple cell towers. And basically a G node B would then be distributed geographically. And that would mean then that you would have many cells controlled by the same G node B. And here it's then even a bit difficult to really talk about what's the site. So you have towers, but you have equipment, which is on different location. Then there is also the beamforming concept, which also enables the possibility to reuse the resources among different beams. And there is some literature and some people who really thought about thinking of beams, basically that each beam would be a different cell, but that was not pretty much the way that was standardized. In 5GNR, we talk about the beams of the same cell. So how actually this cell is defined on the specifications? Well, there is a document called TR21905. TR is a technical report, by the way, and that defines a vocabulary for 3GPP specifications, where you can find the following definition. And this is a document which comes already from the 3G days, but is still referenced by most specifications. So what's a cell in this document? Well, say that the cell is a radio network object that can be uniquely identified by user equipment from a cell identification that's broadcasted over geographical area from one UTRAN access point. The main characteristic is, again, to say that a cell is associated with geographical area, but another important point is that the cell is basically identified. So the identification of the cell is broadcast, and that means that the device which is reading such broadcast can actually identify the cell. It also says that the cell is either on FDD or TDD mode, which is an important consideration of spectrum, as we said in the model 3.1. But what does that mean in practice? It means actually most of the times that the cell is implemented as a combination of a sector and a carrier of frequency. So you would assign during the cell planning these identifiers for each sector and carrier. And that makes a lot of sense from mobility point of view, because those are actually the coverage units. So in each frequency, you have a different coverage. As shown here on the right, for example, if you have two frequencies on the same sector, then quite usually one of the frequencies will have a larger coverage and the other one will have smaller coverage. So here on the left side, for example, if this is the G node B and it's controlling this one tower and has three sectors and one frequency, then would have three cells. And on the right side, if you have then the same thing but two frequencies per sector, then we'll have 6 cells. Well, when we look a bit closer, actually in 5GNR specs there are 2 identifiers for one cell. So there is the PCI, physical cell identity, that's used on the physical layer to distinguish the signals which comes from different cells. And there is a logical identifier, so basically a number, which is the NCGI, NR Cell Global Identity. Let's talk about both. So first of all, the PCI. When we have multiple cells, there is always some overlapping coverage area between the different cells that's needed for the sake of smooth mobility. So that when a device is located in such a position, actually it would receive a relatively high signal from both cells. And it's very important for a number of reasons that the device is able to distinguish if the signal is coming from a cell or another. For example, for the sake of measurements, it would be important that the device is able to report what's the signal level strength for the blue cell and what's the signal level strength for the red cell. And in this area, then it would use this PCI to basically distinguish where the signal is coming from one signal or another. In the logical level, so basically, for example, in procedures like handover or also connectivity to the core, then it's used the NCGI, the NR Cell Global Identity. That's also broadcast on the system information. So basically, NCGI is an hierarchical number which identifies a certain cell globally. And when I mean globally, it's really within all networks around the globe. First, because there is a network number here, basically which identifies the network. And then the NCI, the NR Cell ID, cell identity, which identifies a certain cell within the network. And this number, the NCI, is divided into 2 further numbers. So like the GNB ID, so like identity for the G node B, and the cell identity, cell ID, within a certain G node B. Basically because of the popularity of CRAN, which used to be called mostly centralized run, but now it's more called cloud run, where it's a type of deployment where you have a geographically distributed G node B with a G node B processing unit or the central unit in a certain location. And then you have remote radio heads or radio units on each cell tower. Because of this type of architecture and its increased popularity, then it basically means that a single G node B may need to handle a very, very large number of cells. So for each cell tower, you could have already large number of cells due to many sectors and frequencies. And basically the same G node B would handle all of them. So that's why we have on the NCGI basically a G node B ID and a cell ID. And the cell ID, if you compare it to 4G, you can assign a much larger number of cells. But there are also deployments which go exactly in the opposite direction. And one example is actually in some distributed antenna systems that can be used, for example, for indoor coverage. The complete mobility and coverage is handled on the signal processing level. So actually, despite the fact that you would have multiple transmission points and you would have a certain coverage area, then basically you could have the same cell ID assigned to all of these coverage areas. And everything would then be handled by the centralized processing. It's not to say that all the AES systems works like that, but there are solutions in the market which work this way. So you can have the AES systems which do include handovers and mobility between cells, or you can have the AES systems which just work directly on this signal processing level. And basically then it means if you see like there is not a one solution which fits all cases, or it's not just very immediate to really identify what a cell is in all cases. Let's recap everything we have talked about for a cell in a cellular system. So first of all, the capacity of cellular systems is very large because you have multiple cells. So you divide the coverage area into smaller units, and each of those cells would again reuse the same resources to provide more capacity. That's a very important concept of cellular systems. And the cell is not only the basic unit for coverage, but also it's the basic unit for mobility. So as soon as you are leaving the coverage area of a certain cell, you would need to move to the next cell so that you can have a continued service. Well, still this concept causes confusion. A cell, no matter how it's deployed, no matter how it's implemented by a certain vendor, would actually be identifiable from the point of view of transmission. So you would have a physical layer identifier, which the cells can use to differentiate signals, as well as higher layer identifier, a global identifier for a cell, which can be used logically. And in general, actually would assign such type of identifiers for a combination of sector and carrier, but that's not always the case. As a counterexample, there are some DAS systems which work completely in the signal processing point of view, and actually throughout the whole coverage, even from multiple points of transmission, we would be talking about a single cell with a single physical layer identifier. I would suggest that you learn when people are talking about cell as the coverage area of a site, but try to be more specific. So like if we use terms like sector, like frequencies, then basically we can avoid certain confusions which are caused by the different ways that people talk about cells and the different ways that you can deploy them.